Many processes involve a step where removal of organic impurities out of a liquid is necessary. For this purpose, activated carbon is used as a very effective absorbent due to its large inner surface. The inner surface of a teaspoon of activated carbon corresponds to the area of a football field. Typical applications with activated carbon include, for example, decolorization, deodorization, removal of heavy metals after catalyst usage, or out of contaminated raw materials, or the removal of other organic contaminants. The raw material choice, together with the activation method, influence the pore size distribution, and therefore the adsorption functionality and efficiency of the activated carbon. The pore size distribution is amongst the most important characteristic of activated carbon. The ratio of micro, meso, and macro pores influences the kind of molecules being absorbed, and can be evaluated with standardized test methods using iodine, methylene blue, or molasses. Within the pores of the activated carbon, adsorption takes place. Adsorption is when molecules are adhered to a surface by van der Waals forces. The molecules build a film on the adsorbed surface. Once the surface capacity is exhausted, an equilibrium state is reached. When using powdered activated carbon for decolorization, the correct amount of powder has to be added to the solvent in an agitation tank. Due to the formation of dust, this is done in a separate room, or with special equipment, like a glove box, to avoid dust explosions. The activated carbon suspension is then transferred into the reactor. For the decolorization of the process liquid, the suspension is stirred, in order to achieve the adsorption of the color molecules onto the surface of the activated carbon. Due to this technology's randomness of color molecules coming into contact with the carbon surface, this process can take many hours and might not be 100% efficient. After the adsorption process, the powdered activated carbon has to be removed again from the process liquid with the API. This is done in a separate filtration step, for example, with a neutral filter. ACTIVASORB filters simplify the process tremendously by using the activated carbon in an immobilized form. Inserting the ACTIVADISC filter modules into the enclosed disc star housing is very simple and clean. The use of powdered carbon is no longer necessary, and therefore dust and long stirring times are history. The process liquid with the API is directly pumped to the filter, where the absorption takes place. The right selection of activated carbon will lead to the color molecules being absorbed on the surface of the activated carbon, while the active component will pass the filter unobstructed. All the liquid flows through the filter, which leads to a forced contact of the color molecules with the activated carbon. Therefore, the efficiency of immobilized activated carbon is much higher compared to powdered activated carbon. ACTIVASORB products are available in different forms in order to fit various process needs. Different types of applications have different needs. Therefore, a range of activated carbon types is available. ACTIVASORB products with immobilized activated carbon offer many advantages. Also for your process.